Hi, welcome back. In this module, we'll try to give you a glimpse of a quite innovative biological treatment process, which is feeding biowaste to insect larvae and then harvesting the larvae as protein source. For this, let me introduce you to Stefan Diener. Stefan has been researching this process for a number of years and is really the ideal person to give this overview. Stefan, welcome. And the floor is yours.
Thank you, Chris. And thank you very much for giving me the chance to help you with this module. But first of all, let me also introduce the main actors of this module, the black soldier flies. Are you already excited about them or still grossed out? Here is the outline of this module. First of all, I'll tell you something about the life cycle because we need to know the biology before we can go into the treatment. Then we look at the rearing and then the treatment technology itself. And at the end, we will take a look at the conversion products, which are key for this technology. To put it in a nutshell, fly larvae composting converts different organic sources into valuable end products, which come as nutrient-rich larvae, which can be used as animal feed, or nutrient-rich soil amendments. In this process, we make use of the black soldier fly larvae's voracious appetite. They not only process large amounts of organic material, they do that very fast as well. Watch closely. In this clip, you see them feeding on two rainbow trouts. The one on the right is cooked and the one on the left is raw. As you can see, in a period of about 7 hours, both fish are devoured. Once the larvae have processed the material and gained a lot of weight, they can be harvested, as you can see here. Thereafter, they can be fed to animals. Here we fed them to piglets. And you see and hear how they lost the larvae. Now, let us take a closer look at the life cycle of the black soldier fly. This will help us to understand why this particular fly is suitable for organic waste management. The organism of our interest is the black soldier fly, Hermetia illucens. It has its origin in the Americas, but has been spread over the world by transport of goods and can nowadays be found in the temperate and tropical areas. It's quite a big fly compared to the housefly. It's about 10 times heavier, and its adult lives only for about a week. During this time, it doesn't take up food. That means it does not hop from one food source to the other and therefore cannot spread diseases. Its main activity during the adult stage is pretty simple. It just has to find a mate and reproduce. Now, this is how it works. An adult fly lives for about a week, and during this time it mates and the female lays about 1,000 eggs, close to a suitable feed source. This can be a wide variety of organic material, such as food, market waste, animal manure, slaughterhouse waste, or even human excreta. The eggs take about 3 days to hatch, and small larvae emerge. At this moment, they're only about 1 millimeter in size. These tiny larvae search now for food and feed on it for over a period of 14 days. During this time, they grow from 1 millimeter to around 2.5 centimeters length and finally weigh about 200 milligrams. They go through 5 larval stages before they molt a last time and become the so-called prepupa. These prepupae search for a dry, dark location to pupate and thus usually crawl out of the waste source. Pupation takes about 3 weeks and results in the emerging fly. Now, this was the natural life cycle. We want to use this knowledge now to design a treatment facility. First, we want to manage a breeding and rearing facility which guarantees us a constant supply of fresh young larvae to add to the waste. To reach this, you need to provide the flies with an environment which makes them happy and stimulates them to mate. This means enough light, space, and humidity, or even a water source. In this picture, you see a couple of cages which meet these conditions. We call them love cages. Within the love cage, we provide the female with a medium into which they like to lay eggs, like this sheet of corrugated cardboard. It's placed above a substrate which gives off a strong smell, or you can also say it stinks. Females are attracted by the smell and fill the holes with eggs. Here you see a few females which are just about to place their eggs into the openings. On the right picture we see the egg packages that fill the holes, for example here and here. Each package contains 800 to 1000 eggs. Once the larvae have hatched, we keep them in the nursery for 5 days before adding them to the biowaste. Ideally, you prepare the waste by grinding it up so that the larvae can feed easier on it. Typically, we add a defined amount of larvae to a given amount of biowaste. The ratio, however, varies depending on the substrate. For food waste, for example, we need about 8,000 larvae to treat 1 kilogram per day. After they have fed for about 2 weeks, the larvae are ready to be harvested. By the time we harvest, the wet waste has been reduced by 80 to 90%. Although this approach can be considered quite new, if you search the internet, you will find a lot of videos, pictures and small-scale systems that people have experimented with or are even for sale. Most of them make use of the prepupae's habit to crawl out of the material and offer therefore some sort of ramp to harvest the protein-rich prepupae. In most of these systems, you do not maintain a separate colony or nursery like I described before, but you rely on natural reproduction and assume that females are attracted by the smell of the waste and lay enough eggs to keep the process running. On the other end of the spectrum, there are a few large facilities operating in different parts of the world. They are all designed to process more than 60 tons of waste per day. For some of them, revenue comes not only from selling the harvested larvae, but also from the treatment fee, meaning that they are paid for taking the waste from the one who generates it. But you may ask, why are people so eager to use this fly? Of course, the waste reduction is impressive, the process in general fascinating, but honestly, it's all about the products, the residue and the larvae. The residue is similar to vermicompost. You get about 100 to 200 kilograms per ton input, but you have to keep in mind that the BASF process does not kill all the pathogens that are present in the waste. That means if we have an input source which is contaminated, we need a sanitizing post-treatment step for the residue. This also applies for the larvae, our second product. Depending on the input source, you can harvest 100 to 200 kilograms per ton. The larvae, they consist of 40% protein and 30% fat. This makes them an attractive feed source for animal, and they can replace the fish meal nowadays used in animal feed. In the chart, you see the development of the price for fish meal over the past 15 years. As you can see, it tripled in the past 10 years. The reason is the demand has increased because there is much more aquaculture today than ever before, and the wild fish population, on the other hand, is depleting. With increasing fish meal prices, the larvae become an interesting option for both the animal feed producer on one hand, but also for the waste manager, because selling the larvae at a good price helps covering the treatment costs. Let me summarize what we just learned. Just like it's the case with worms in vermicomposting or bacteria in anaerobic digestion, we have to know the life cycle and the preferences of our target organism in order to optimize the treatment technology. So we learned about their huge appetite, which leads to the reduction of about 80%. But it's not only about the waste reduction, it's also about the larvae production, meaning that from 1 ton of waste, we can harvest up to 200 kilograms of larvae. They replace fish meal in animal feed, and there are existing backyard applications and some large-scale operations. I hope your disgust has now transformed into ecstasy. Thanks for watching and goodbye.